All right, thank you. So glad to be here, everyone. My name is David, and I'm from Nigeria. And I'm going to be talking or speaking to this community about best practices for writing clean and maintainable codes. All right, so a quick overview of the presentation. First, I would be looking at the importance of clean and maintainable code, and then followed by definition of what code smell is and listing of common code smells or issues, as it were. And then three, the next item would be refactoring or looking at refactoring concept and techniques to fixing code smells. Next by that, I will quickly touch on team culture and influence on practices that could aid clean and maintainable code. And finally, key principles. I'll be looking at key principles for writing clean and maintainable code um, to help developers across the world to improve or deliver or write clean and maintainable codes. All right, quick one. So why are clean and maintainable codes crucial? First, and just basically, I like to deep dive into the key nuggets. Then the first thing is that clean and maintainable codes are crucial because it makes debugging and enhancement of codes very, very easy. I mean, easier to read, easy to understand, making it simpler to identify and fix bugs. Also, in that same line, it also helps reduce the time and effort required to debug and enhance codes. And secondly, it's quicker. I mean, it aids faster development cycles or makes development cycles very fast. It also makes or contributes to faster resolution of issues. Uh, Typically, you run into bugs and you imagine that someone else needs to join in reviewing that code in order to quickly fix the bugs. The issues, a clean and maintainable code is a sure foundation to ensuring that bugs or issues are easy to resolve and fast to resolve. Thirdly, it improves team collaboration. By team collaboration, I mean it helps teams to easily understand each other's work. And also, as a result of that, it facilitates contribution or insight. It also enables more effective peer programming and code reviews. Fourth one or fourth item is it contributes to scalability and adaptability, meaning that it makes it easier to scale and adapt to new requirements as fast as possible. And the last one that I like to touch on regarding the importance of clean and maintainable code is that clean and maintainable codes adds the code quality and reliability, which is one of the essence or reason why we are here. Okay, so what is code smell? Code smells are indicators of potential problems in the code that, say, for instance, while not necessarily bugs in and of themselves, but they suggest deeper issues that could hinder readability, maintainability, scalability, and some of those benefits or importance that I shared earlier on in the previous slide. And so basically, they are not necessarily bugs, but they could hinder readability, maintainability, and scalability of software. So code smell. Some of the code smells or common code smells, for instance, comment, that is, too much comment may indicate that the code in itself is not quite clear enough. Which typically leads to, say, for example, having to, excessively hard comment in order to help whoever is going to read or rewrite or refactor at a later time, or even improving by the same person to understand what has been written. Secondly, code smells or common type of code smell. The next one is duplicated code. This is identical or very similar code that exists in more than one place within a code base. The problem with this is that it increases maintenance effort because changes needed oftentimes needs to be made to multiple places where the codes have been duplicated. The third common code smell is long method, meaning methods that are excessively long and they try to do too much at once or packed together. The problem with this long method is that it's harder to understand and it's harder to maintain and also test. The fourth item or the fourth common code smell is large class, right? You have too many responsibilities and contains too much code in the class. And this, I mean, as written here, the problem is that this violates the single responsibility principle, making the class harder to manage. The fifth common code smell here is refused request. That is a subclass that doesn't use all of the inherited methods and properties. And the problem with this is that, for instance, or the way you could identify this is that it's possibly going to indicate a possible incorrect inheritance relationship type. There are some other code smells or type or common code smells. Others are, for instance, divergent change, shotgun surgery, speculative generality, and so on. You could potentially, look some of these other ones up to gain more insight into them. Next is identifying and analyzing code smells. So, for example, in order to basically understand or identify code smells in a code base, one of the things that you could potentially use, because it could be quite challenging, as you may have seen in the previous slide, it could be quite challenging to spot. And so the way to, or one easy way to particularly approach this would be to use automated tools, for example, static code analyzers, and some other tools like that that could help identify common code smells. Some of these tools are like, for instance, Reshaper, even PyLint could help facilitate automation of identification of an analysis of code smells. And then code review, particularly or majorly manually, or being done manually through peer review. For instance, you have a colleague or a more senior engineer on the team who is taking a look at the code, could potentially spot some of those smelly code, and without necessarily using a tool, or that the tool might actually miss in itself. All right, so the next is, I haven't understood what code smells are, or the issues that could impact the ability to, or delivery of, or writing of clean and maintainable code. The next would be, how do we now refactor? Haven't understood how to identify those. And the approach is basically refactoring, which is the process of restructuring existing code without changing its external behavior. That is not necessarily modifying the functionality that the code was built to perform. And so, so what are the refactoring techniques? We have, for instance, extract method. That is the breaking down of a long method into smaller, more focused methods. I wish if this was a workshop section, I possibly would have been able to deep dive into practical showcasing some of these techniques. However, we could take some of this insight up and in various teams look them up or consider them and see how they work in real life. So the next one is the move method, that is moving a method of field to a more appropriate class. This is possibly something that we subtly do or knowingly do, or sometimes do, or that some people already do. Basically, moving a method or field to a more appropriate class could particularly help, remove smelly codes or fix smelly codes, particularly related to, say, for example, long method and all of those. Third technique here is renaming variables, basically changing variable names to more meaningful ones. So this particularly, helps to, say, for example, fix or reduce or could potentially impact, say, for instance, the number of comments that needs to be made or put into a code base. And then the fourth item here is introducing parameter object, that is replacing long parameter with a single object parameter by basically using classes. The next item here is team culture and practices and understanding how they could impact, for example, the writing of clean and maintainable code. The first item that I have here for consideration is encouragement of best practices, meaning that is, it's imperative for us product engineering teams or software engineering teams to have a culture to ensure that there is a culture that emphasizes the importance of best practices. For example, whether during stand-up meetings or during reviews, code review sessions or whatever time, but it has to be inbuilt into the culture right from the onboarding of a new team member, such that the person coming in to join the team understands the emphasis of the characteristics, the quality, or the values that the team precisely holds in terms of, say, for example, writing clean and maintainable code. Also, in addition to that, I have peer programming and continuous integration that leads to higher code quality. So encouraging best practices potentially helps improve code reviews, peer programming, continuous integration, and potentially could lead to higher code quality. Next is the collaboration and communication. That is, this could potentially facilitate open and effective communication within the team and potentially foster collaboration, allowing the team to share knowledge, identify issues early, and work together to fix or to find the best solutions to an issue. Third item here is accountability and ownership, basically encouraging the team to take ownership of their code. And this in itself can potentially make individuals more likely to care about its quality right from the get-go. And the fourth item here is adoption, which is somewhat similar to the first item that I have listed here, but basically emphasizing that there is need for adherence to coding standards. So whatever standards are adopted within a team, which forms part of the best practices for the team, it's imperative to ensure that there is monitoring and adherence to that coding. So engineering managers need to take particular responsibility for ensuring that some of the things that are identified as best practices are being monitored and being done according to the coding standards adopted. All right, so the Next item here is the key principles for writing clean and maintainable code. And the first here is, like I mentioned, this could form like part of the best practices or things to put into the best practices or code for best practices. And the first thing that I have here is the keep it simple, stupid, right? It's an acronym. Excuse me. It's the acronym is KISS, right? And it basically means that we need to ensure that we strive for simplicity in our coding by avoiding unnecessary complexity in the coding. And the benefit of this is that it simplifies the coding process in itself. It helps to deliver simple code that is easier to read, easier to understand, and easier to maintain. And also, in addition to those, it also helps to avoid over-engineering solutions and implement straightforward logic. This is like an umbrella principle that every team needs to ensure that it's in the toolbox, along with some other set of principles for that could go into the best practices that will be adopted. The next item here is dry, which means don't repeat yourself. Basically focuses on avoiding duplication of codes, whether it's a method or whether it's a function, maybe not necessarily a function, but methods, and also okay, and functions themselves, basically to avoid excuse me. This could help avoid duplicating code by abstracting out common functionality into reusable components. And it also helps to reduce redundancy, making the code base easier to maintain and less prone to error. For instance, you have the same block of code that is used in multiple places. Refactoring it into a single method or function can that can be called from different locations could help fix or could help align the team with don't repeat yourself or avoid duplication of code. Then the next item or next key principle here is YAGNI. That is, if you aren't going to need it, don't add it. Really. So this principle basically, teaches or helps or could help team to avoid adding unnecessary functionality to a code base, except and until when it is actually necessary. And basically, just implement features and functionalities that are necessary at the moment of deployment, and not those that we think might be needed in future. This is particularly important because, for instance, when you are doing, let's say, traceability of requirement or validation of requirement, this could potentially impact that ability to validate or say, for example, go into developing test cases appropriate for validating that specific requirements have been met. Next is the solid principles, which has quite a number of subsets. And on that list of the subset of solid principles is that first, single responsibility principle, which states that a class should have only one reason to change, meaning it should have only one job or responsibility, nothing more, nothing less. Next is open and closed principle, and it basically states that the software entities should be open for extension, but closed for modification. List curve substitution principle. This states that objects in a program should be replaceable with instances of their subtypes without altering the correctness of the program. Next is the interface segregation principle. Basically states that clients should not be forced to depend on interfaces they do not use. And lastly, on this list is the last item on this list is dependency inversion principle. And this basically states that high-level modules should not depend on low-level modules, meaning both should depend on their respective abstractions, right? Some other key principles are modularity, which is breaking down the code into smaller, self-contained modules, making the code base more manageable, reusable, and easier to test. Other key principles that could be adopted are encapsulation and testability, possibly or potentially some that we currently already have in our tool set and that has formed part of what we use in our everyday practice. But these are some of the key principles that I think could significantly impact and improve writing of clean and maintainable code. So this leads me potentially to the end of the focus on this presentation. So quick takeaway, we've looked at the importance of clean and maintainable code. We're seeing that it could potentially impact or help us improve debugging and enhancement of code, particularly making it easier to read and understand. Also touch on the ability to make it simpler to identify and fix bugs. Also worthy of note is that it could potentially reduce the time and effort required to debug and enhance the code. Also, it has potential to increase the development, speed up the development cycle, and increase resolution of faster or leads to faster resolution of issues. Importance also, one of the key things that is also important to take away is that it improves the team collaboration, particularly helping team to easily understand each other's work, and particularly aiding the ability to, have colleagues or peer review, contribute to the code review through peer review or during peer review. Finally, it also could, aid scalability and maintainability, which is also critical to ensuring that we are able to deliver clean and maintainable code. I also touched on code smell, defined what code smell is, listed common code smells. But I don't want to go into all of those. We could, watch the video later on to deep dive into some of the concept already taught, particularly regarding the types of common code smells and how to identify all of those. I also touch on refactoring, which is basically how to improve, identify and improve code smells. And I also touch on team culture and influence on practices. And finally, which was the last slide, before I move to this, the key principles for writing clean and maintainable code. And this leads me to the end of my presentation. Thank you.